If the planet is going to see more extreme hot weather and even droughts in the coming decades, what can we do to protect millions of people that would be affected? And why are the environmentalists who care most about climate change apparently lined up against some of those measures? Well, let's find out. My name is Mallen Baker. This is the Mallen Baker Show for change makers. Arguably, the issue we're talking about in this video is made more important by the anticipated effects of human-caused climate change. But even if you're not much impressed by the predictions that come from that, there are still plenty of reasons to give this some attention. Throughout human history, we've seen frequent periods of extreme temperature and drought. Those periods could sometimes be devastating to human societies, and it could be worse in the future. We're massively increased human numbers, the sign of our success. As a result, we now depend heavily on certain major breadbasket areas in the world to provide sizable proportions of our food, and that increases our vulnerability to extreme heat and drought. In the last few weeks, a major breakthrough in genetic modification has given some real excitement about our ability to be resilient in the face of such a crisis. Modified seedlings for a type of mustard plant were able to survive extreme heat in the laboratory over 8 hours at 41 degrees centigrade. Most of the control plants were killed, and the modified seedlings showed stronger photosynthesis and growth than those control plants that did manage to survive. The genetic technique was tried in 3 different types of plants: mustard, tobacco and rice, and it was successful for all of them, suggesting it could well be successful for any type of crop plant. Some of the rice was then trialled in test plots in Shanghai, and when the Shanghai weather went above 36 degrees centigrade for 18 days, the modified rice gave up to 10% more yield than the control plants. Not only does the crop survive the heat extremes better, it also provides more photosynthesis and yield when the temperatures are normal. The transgenic rice, for instance, gave 20% more grain. How does it work? One of the key proteins that's part of the system powering photosynthesis is a protein called D1. Excessive heat can damage the D1, which weakens the plant's ability to photosynthesize until a new D1 can be made and reinserted back into place. This takes place in the chloroplast, which is the organelle within which photosynthesis takes place. Unlike the plant cell's nucleus, it's a lot harder to modify the genes of the chloroplast. What the researchers did in this case was to try adding the D1 to the nucleus DNA instead, and it apparently worked. There's a lot more testing to be done. In spite of the benefits shown by the plants, some people are not convinced that D1 made in the nucleus could have repaired damage in the chloroplast. But nevertheless, the results are incredibly exciting. Rice is the most important staple crop in the world. More than half the global population eats it every day. Higher yields and more resiliency would be hugely beneficial. Now, you think that the activists most concerned about climate change would be similarly excited about these sorts of results. They worry, after all, about the impact of such climate change on the breadbasket areas of the world. So this is incredibly important in addressing those worries. Well, maybe they will be, but not on the evidence of what we've seen so far. Not on the evidence of, for instance, the history of a similar project, that of golden rice. Golden rice was developed as a project funded by philanthropy and the public sector because its aims are wholly humanitarian. For some people, 70 to 80% of their calorie intake comes from rice. The problem is that while it's an excellent source of energy, it doesn't provide other essential nutrients. And in a number of the countries where rice is the staple, deficiencies of those micronutrients is a real problem, particularly where there's significant poverty, where foods providing good levels of micronutrients are generally more expensive than the rice. One particularly common problem is vitamin A deficiency. So Professor Ingo Petrikas and Dr. Peter Bayer set out to create a source of vitamin A that would be contained within the endosperm of rice. The endosperm is the bit that you have left over once the rice has been polished. A lot of development work went into it. Eventually that work paid off, and with a golden hue of beta-carotene in evidence, golden rice became a reality. It underwent a number of safety studies, came through with flying colours. Writing about the early days of a project, Professor Patrika said this: "The concept of using the potential of genetic engineering technology in a public sector project for the public health of poor societies was welcomed with sympathy and even enthusiasm by the scientific community, the media and the public. Golden Rice experienced an overwhelming recognition, even making it to the cover of Time magazine in the US and Asian editions." However, with that sort of profile, the project also attracted the notice and inevitably the opposition of anti-GMO activists. And we ended up with a deeply polarised debate, with anger fuelled by moralism on both sides. To understand this, let's look briefly at the arguments for, the arguments against, and then the part where the real challenges lie, which is the obstacles still to be overcome. When it comes to the arguments for, there's an emotive hype version and there's a pragmatic version. The emotive hype version is this: tens of millions of people in India, China, Bangladesh and throughout South and Southeast Asia suffer from vitamin A deficiency. Golden Rice can save them from going blind or from dying from this deficiency. It's ready, it works, and every additional delay to its introduction is an unconscionable crime against humanity. And the anger in that last part comes, according to its proponents, from the injustice of 20 years delay that arises from the actions of anti-science campaigners. When I first started looking at it, I rather assumed that was going to be the position I ended up supporting. But you come at these things with an open mind, you discover all sorts of aspects. You can supplement the hype with some more pragmatic arguments of detail. There are already ways that we can address vitamin A deficiency. Distributing vitamin A supplements has been a focus for numerous programs, and those programs work. A 2017 review found that vitamin A supplementation in children 5 years old and younger in 70 countries saw a 12% reduction in mortality rates. But that same study also acknowledged that for practical and cultural reasons, such supplements might not be the best long-term solution for vitamin A deficiency, rather than food fortification and crop improvements, for example, golden rice or a vitamin A rich sweet potato. The Philippines has become an early area of focus. In the Philippines, vitamin A deficiency has been going down due to supplementation programs, amongst other things. But deficiency remains a public health problem, affecting more than 1.7 million children under the age of 5 and 500,000 pregnant and nursing women. Many of those still at risk live in areas that are hard to reach with supplementation programs, hence the value of augmenting the most commonly eaten food with the missing vitamin. And that's the point. The people at risk are at risk because they don't commonly get the vegetables that are good sources of vitamin A naturally. But they do eat rice. And the poorest will find more nutritious vegetables cost more than the base rice, and so it's the rice that they end up eating. Now, rice is perfectly good fuel, high quality carbohydrates, but it's not a source of micronutrients. So that's a case in favour. When it comes to the activists, the anti-GMO campaigners, ultimately there are a couple of basic reasons why they object, and then they may add some situational items on where they see an advantage. The principal objection arises from the environmental campaigners' mainstay, the precautionary principle. They say that genetic modification in general runs unknown and to a large extent unknowable risks. They argue that nobody fully understands the consequences of messing with genetic material, and it's entirely possible that in trying to introduce something beneficial, or worse from their point of view, just something commercially advantageous, you could unwittingly create something that has harmful implications to human health or to the environment. And you also run the risk that once that genetic material has been released, cross-pollination and human agency will mean that it can never be recalled again. Plus, there are certain value judgments you'll find in the literature of the campaigners as well. Often that genetic modification is being driven by corporations looking to enhance their profitability. Sometimes maybe that comes in the form of features that customers find desirable, but a lot of the time it comes from things that boost the bottom line, but without any benefits to consumers, or even worse, such as crops that are resistant to certain pesticides or herbicides, so they can be treated more effectively in the field. The campaigners will demonize certain companies such as Monsanto and take it as given that anything beneficial to Monsanto must by definition be damaging to people. Take away the hyperbole and it's essentially an argument that the benefits are not shared with the growers or the consumers. Obviously that last one arguably doesn't apply in the case of golden rice. There's another value judgment thrown in there as well, an emotional reaction against humans messing about with the very stuff of life, interfering in nature. It's against the natural order of things. One article written by researchers in the field gave an articulation for it in relation to golden rice. But it's not rice's job to provide vitamins. Most diets across Asia and Africa consist of a carbohydrate core such as rice or maize, which provides calories and bulk, and a sauce, stew or soup for flavour and nutrients. Since rice is a poor source of vitamins and minerals, any child eating a rice-only diet will be sick. Genetically modifying rice to contain beta-carotene is at best a band-aid for extreme cases of vitamin A deficiency, not a corrective for a widespread problem. Which is a practical way of saying it's against the natural order of things. Get proper food to all people so they can eat balanced meals the same way that everyone else does. Don't mess around with the nutrition of one element in order to elevate it above all else. And you'd expect the proponents of golden rice would probably respond to that it runs the risk of making the perfect the enemy of the good. If something's happening in a certain way at the moment, then saying it would be better if that weren't the case is all well and good, but it's that way for a reason. Changing the nature of the status quo may have more impact than insisting that nothing should be done until more widespread changes can be made. It's not as though modifying the rice in the short term is stopping anyone from getting people to eat differently in the long term. They're not really mutually exclusive. Anyway, those are the key arguments against. Sometimes those against will also grab onto obstacles, suggesting that they're obstacles that can't be overcome. Sometimes they might be right, and sometimes they're not. The campaigners will use any and every weapon that comes to hand, but many of those obstacles may well be solvable. That said, there's at least one highly formidable obstacle that it's not immediately obvious will be overcome. Maybe two. The first is the open question of whether golden rice will actually work. It has to provide enough vitamin A to correct dietary deficiency in the poorest people in the country. The first version of the rice didn't provide a sufficiently high concentration of beta-carotene to do that. The updated version now appears to. However, it's not clear whether the beta-carotene will be absorbed effectively by the body. Trials have been done which show that the rice was nutritionally successful, but it was provided with a full balance of other food elements, particularly fats. Vitamin A is fat soluble. The presence of fats in the food helps it to become absorbed by the body. But it can well be the case that the children who suffer from vitamin A deficiency rarely have fats in their diet. And they may also suffer from gut parasites and infections that may also make it harder to convert beta-carotene to vitamin A. So will it actually work in the conditions where it's actually needed? Maybe. The trials done to date don't prove it either way. But the more difficult problem is this. Will the rice actually be attractive enough to the farmers to make them want to grow it? Because it's all well and good having a product designed to hit one specific hard-to-reach group. But how's it going to be grown? And how's it going to be distributed? It's the human element and the very last thing that scientists focused on the product idea are going to consider. In theory, it's simple. The golden rice proponents have said that the crop will be provided free of charge to growers in poor developing countries. But apparently there's no mechanism for that. The owners of the intellectual property behind the genetic modification have waived their development fees for some of the farmers, but nobody's on hand to distribute the rice to farmers for free. A recent study looked at what would be the likelihood that farmers would actually embrace the crop in the Philippines. The top areas for vitamin A deficiency in the Philippines are Mountain Province and Marikina City. In the case of the former, the fact that so far golden rice has been bred into lowland rice varieties makes it pretty unlikely that Mountain Province farmers would adopt it. In the case of the latter, virtually no rice is grown around Marikina city, so if the grains are going to reach the populations there, the seed would have to be grown by commercial rice growers in the key rice growing provinces, like Nueva Ecija. In those areas, farmers replace the seed they grow periodically based on what's fashionable, what's thought to be high performing, and what's seen as desirable to the marketplace. When golden rice decisions were being made in the early 2000s, RC82 was chosen as the main variety to be adapted, since at that time it was seen as an emerging variety they thought would still be popular with farmers when the golden rice was released. RC82 spent a couple of years as the most popular rice variety, but was dethroned soon afterwards. The golden rice modification was also added to IR64. Both varieties are no longer seen as competitive in yield and are planted by very few farmers. The key question is why farmers would choose to grow golden rice. They're not the targets for it themselves. They don't suffer from vitamin A deficiency. The bulk of the market that they serve doesn't suffer from vitamin A deficiency and therefore isn't likely to demand the product. Are they really going to take up golden rice in order to sell to a distant minority poor marketplace? There's currently no proposition that makes that a lucrative prospect for the farmers. By and large, the research showed that the communities of rice farmers have their own views, surprisingly enough, of what's good to plant. They aren't necessarily swayed by promotional campaigns or even by government subsidies. Now, how solvable a problem is this? In theory, golden rice can be added to popular and higher performing cultivars of rice. It would need to be able to be added without affecting the things that make those strains popular, particularly yield and overall quality. But that sort of process takes quite a long time. So the question is whether you end up in a constant losing race, trying to adapt the popular cultivars of today, only to find that the market has moved on once again by the time you get there. And even if you do catch up, the question still remains why the farmers would choose to grow this version rather than the version they already know when nobody in their market is demanding it. I mean, even the would-be beneficiaries of the product are not demanding it, since they don't really know that it exists. They don't get much of a voice in the marketplace anyway. It's a classic problem of how things sometimes play out when smart people come up with solutions to problems that they then try to do to people rather than working with people. It could well be that golden rice will not be defeated in the end by the radical campaigners whose response to any genetic modification is a morally outraged no. It'll be defeated because although it's a great idea, it doesn't have the traction on the ground. It doesn't work with people the way they are, with all their flaws and all their foibles. Now, of course, that could still be a solvable problem. Government could create powerful incentives. A commercial company could decide to drive it forward. You could get a multinational corporation growing golden rice to be imported into the areas of need, bypassing local growers. Who knows? But that sort of solution requires champions other than the scientists who had the original idea, people who can organise and push to scale. Now, what does all this history tell us about our exciting new innovation we talked about at the start? Well, on the one hand, it's a cautionary tale. There has to be more than just a breakthrough and an idea. There has to be an organisation based on a commercial proposition. But the new breakthrough has a number of advantages. It offers a higher yield under all circumstances. That's a benefit that will appeal to mainstream growers. It offers a higher yield, particularly in instances of extreme heat. Likewise, a benefit that will appeal to any growers that have recently been hit by such conditions. Which means that the only obstacles to be addressed, will be perfecting the technology and then navigating it past the anti-GMO forces that will oppose it. And if you think it's strange that the people opposing it most vociferously are probably the same ones who say we have to take serious action on climate change, well, yeah, that's strange. But it's the world as it is. So that's the world we have to engage. I outlined the two positions for and against golden rice. Both sides are now heavily bunkered in, both convinced they're on a moral quest to save lives, utterly certain that they are on the side of the angels. We probably don't get to the best outcome on this process by digging ourselves into either of those ditches. Rather, keeping a clear, science and systems-based view of what will work, what will be the benefits, and whether it can be made to work in practice. Given what's at stake, it seems to me that really shouldn't be too much to ask.